Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the composition of a gas mixture. We have limited our consideration to thermodynamic systems that involve a single pure substance such as water. Many important thermodynamic applications, however, involve mixtures of several pure substances rather than one single pure substance. Therefore, it is important to develop an understanding of mixtures and learn how to handle them. In this project, we deal with non-reacting gas mixtures. A non-reacting gas mixture can be treated as a pure substance since it is usually a homogeneous mixture of different gases. The properties of a gas mixture obviously depend on the properties of the individual gases, as well as on the amount of each gas in the mixture. Therefore, it is possible to prepare tables of properties for mixtures. This has been done for common mixtures such as air. It's not practical to prepare property tables for every conceivable mixture composition. However, since the number of possible compositions is endless, therefore, we need to develop rules for determining mixture properties from a knowledge of mixture composition and the properties of the individual components. We do this first for ideal gas mixtures and then for real gas mixtures. The basic principles involved are also applicable to liquid or solid mixtures called solutions. Let's first talk about the composition of a gas mixture, mass and mole fractions. To determine the properties of a mixture, we need to know the composition of the mixture as well as the properties of the individual components. There are two ways to describe the composition of a mixture. Either by specifying the number of moles of each component, called molar analysis, or by specifying the mass of each component, called gravimetric analysis. Consider a non-reacting gas mixture composed of K components. The mass of the mixture is the sum of the masses of the individual components. That is, the mole number of the mixture is the sum of the mole numbers of the individual components. That is, the ratio of the mass of a component to the mass of the mixture is called the mass fraction. The ratio of the mole number of a component to the mole number of the mixture is called the mole fraction, and the ratio of the volume of a component to the volume of the mixture and standard condition is called the volume fraction. Let's talk about the conversion relationship between each fraction. For ideal gas mixture, we have. This means that For ideal gas mixture, the mole fraction is numerically equal to its volume fraction. After the molar mass of a mixture is defined, mole fractions can be converted to mass fractions. By this way, mole fractions can be converted to mass fractions. Also, based on the known molar mass of a mixture, mass fractions can be converted to mole fractions. By this way, mass fractions can be converted to mole fractions. The molar mass M mix and the gas constant Rg mix of a mixed gas can be found by the composition. The molar mass of a mixture is, you can say the molar mass of a mixture can be determined by either mole fractions or mass fractions. The gas constant of a mixture then is. Okay, that's all for this task. Thank you very much and see you next time.